Hello. I received a lot of emails saying that you need some help with answering the questions, so I would like to help you with that. So when you do the experiment, let's say that you have a length of 1 and for doing the 5 cycles, which is to go and come back, which let's say that no, it took 10 seconds. So I'm going to divide this number by 5. So each took 2 seconds. I'm just giving some approximated numbers. So do not quote on me that they will take so long or so less time. Okay. Now, so I have a 4, which is this square. I got it as a 4 right here. Now I need to calculate the theoretical period, which is using this formula right here, using the my length value L, and the G is 9.8 because all the lengths are in meters. So I'm going to use G 9.8 and calculate this number right here, and I'm going to put it right here. And I'm going to check whether I got the numbers exactly same as the theoretical one according to the fixed length. I'm going to repeat the experiment for various lengths, which is again I'm going to go with 0.75, zero point 0.5, and 0.25, and so on and so forth. So according to that, my time will probably be 8, maybe 7, maybe 6, and I'm going to do 8 over 5, 7 over 5, and 6 over 5, and whatever the number you get, I'm going to square it and put it in the column 1, 2, 3, 4, 5. Okay, so now what I'm going to use is I'm going to use all these data values in these questions right here. So my first question would be based on the answers we get right here on the table 1, which is the time period would depend on. So we did the measurements of changing the length, changing the, let's say that if we change the G value, if we change mass value, if we change the angle at which we try to make it bounce. So based on those, we are going to find it out whether it is going to be dependent or independent on. So based on the observations you get it from table 1, you would be answering this question whether, so I'm going to give you a clue of look at the length, G value, mass, and angle at which we are going to throw them. Okay, so these are the ones we are going to, so we are going to check and we are going to put them in 1, 2, 3, 4. So which one are going to be dependent and which one are going to be independent of. Okay, now we're going to go with calculating the slope. So we are going to pick any two values from the table 1. So I can pick this value or this value or this value or this value. So I'm going to go with the graph which is shown right here, which is I have length on the x-axis and t square on the y-axis. So let me calculate t square right here just for the ease of it. So I'm going to do these calculations right here, 8 over 5, which is 1.6, and 1.6 2.56. And then here 1.96, 1.44. So I got the values of length and t square. So my graphs should be length versus t square. So I'm going to pick two values. So I'm going to pick any two values. I can pick any two values. So I'm going to pick this and y value as this. And then I'm going to pick this one as x2 and this is as my y2. Okay, I'm going to find the slope. So my points are 1, 4, 0.5, 1.96. So those are my x1, y1 and y2, x1, y1 and x2, y2. Okay, so I'm going to do the math right here in order to find the slope of that graph, which we are going to get it right there. Okay, so that's going to be 4 minus 1.96 4 minus 1.96 divided by 1 minus 0.5. So this is what is going to give me the slope. Okay, so whatever the slope you get right here, that's what you're going to use to find out the theoretical slope. So if we were to calculate with that particular length and that particular mass or so on and so forth, what would be the slope? So that's going to be 4 pi square over g. So this is the way we should get the slope, which is pi value is 3.14, and plug in that and see how much value you get. So, and I want you to find out theoretically you are supposed to get this much of slope, and if this is the slope, and this is the slope right here, and then experimentally if you want to find out the g experimental, that's nothing but 4 pi square over the mu calculated from here. Okay, so let's say I'm just going to calculate that number right here just for your ease, but as I already said, these are just random numbers I'm going to give you, so you need to go with your own numbers. Equals to 2.04 divided by 0.5. So I got an answer as 4.08. Okay, so according to my experiment, I got my slope as 4.08. Okay, and I'm going to use that slope value right here to find out how much would be the slope, how much would be the g experimental. So g experimental, you should get this one. So g experimental would be 4 pi squared, which is 4 times 3.14 square. And divided by 4.08, which we just got it as this number right here. Whatever the number you got right here, I'm going to use it right here. Okay, so that's when I calculate that, that's going to be 9.66. So according to, I'm sorry, not right here. Okay, meters per second square. So according to our experiment, we got 9.66. And in real, the G value is 9.8. We got 9.66. So it means we made a small, teeny mistake. So we need to find out how much is that error percentage. In order to find out that, we're just going to use this formula given right here. So 9.8 minus 9.66 divided by 9.66. And whatever the answer you get, that's what is your error percentage, which is 9.8 minus 9.66 divided by 9.66, which is going to be that. So I got about approximately 1.5 percentage error, 1.5. It means I am pretty much like 98.5 accurate. So which is pretty good, right? So this is how I want you to calculate your own experimental slope, and then based on that slope value, I want you to find out your G experimental, and I want you to find the error percentage ultimately. Okay, so I hope you understand it now. Then if you have any questions, feel free to shoot an email to me. Thank you.